This is a chi-squared test of independence. What we're going to do is we're going to do the whole of this using a graphic display calculator, a Casio graphic display calculator, right from start to finish, right from choosing the hypothesis to finishing with a conclusion. So first of all, if you read the question, we've got 3 political parties and how people have voted split by gender, male and female. We want to see, are the votes independent of the gender? And that becomes our null hypothesis. Our null hypothesis is always independence. So there's always independence between the things in the table. And the alternate is they're not independent. I'm also going to now write down the alpha value, which is the level of significance, which is 5% for this one. And that's just stated in the question. And I'm also going to explain what the degrees of freedom are, because you might be asked to write that down. So the degrees of freedom, simply the rows, I've got 2 rows, and I take one away rather from the rows. So obviously 2 take away 1, and I times it, 2 take away 1, and I times it by how many columns I've got, and I just take 1 away from the columns as well. So it's a pretty simple, straightforward thing, is 2. Now you might be asked for that. Now we're going to go ahead and find some chi-squared values. And for this, we're going to have to take our calculator. So let's grab our calculator. Let's go into the statistics mode. And we're going to do a test. And we're going to do a chi-squared test. You also have the goodness of fit, which is a separate topic, but we're going to use two-way for independence. So let's click on that. And you ask for MAT A. That stands for matrix A. So I'm going to choose matrix A, and that's my observed. And I'm going to put this into a matrix. Now, if I come out of here, I haven't set up my matrix yet. So I'm going to go into the Run menu, and I'm going to choose the matrix I want. Now, that matrix, let's have a look if it's 2 by 3. 2 by 3 is perfect. So I'm going to put these values in, not the totals. So 60, 110, 110, 90, 130, and 100. Now those are in. I can leave there, go back into my stat menu and try again. So remember, I was doing a test chi two-way. Now it will accept that. Now I didn't set up matrix B, but it's going to fill in matrix B for me. And these are the important things that I need. I need chi-squared and P, and you can see that degrees of freedom have been worked out for me. So let me jot those down. Chi-squared, and this is the test value, is 5.5, and the P value is 0.064. Now I'm going to interpret those, and I'm going to do it in 2 ways. You're generally going to use the P value. Now, if you've done the t-test, you know that we had a curve. Well, this is the chi-squared curve. And at the 5% level of significance, this here is 5%. This is the alpha value from the previous one. This is the level of significance. And in here, I reject HO. So it's very similar to the t-test, where we reject if we're in the shaded part. And that means that in here, we accept HO. Now what we're going to do is we're going to fill in, we're going to find what this cutoff point here is. And again, I'm going to use my graphic calculator. So let's grab that graphic calculator again. And for this, I'm going to come into the stat menu again. I'm going to go to distribution, chi, inverse chi. I'm going to set this up to be variable, and I'm going to say that I want 0.05 and 2 degrees of freedom. And my cutoff point is 5.99. Now, if you remember what my chi-squared test statistic was, it's in here, and it was 5.5. It's not in the shaded region, so I'm going to accept HO. I could think of it the other way. The way that IB has moved towards now is using the p-value a bit more. So if I come in here, and the p-value, sorry, that is 0.05, and that's my critical value. And then my p-value is here. It's before I get to the 0.05. This goes down to 0 here. And my p-value was 0.064. So this is another way of thinking about it, is that I am still in the white region with the p-value. So we've got these two different ways. But either way, we're going to end up with the same conclusion, and that is, because we're not in that shaded region, we're going to accept H0.